Hello students, welcome back to my channel. In this video I am going to discuss in brief about the supercapacitors. Supercapacitor can be defined as a capacitor of high capacitance with low voltage limits and high power density. So a supercapacitor can be defined as a capacitor of higher capacitance. The higher capacitance is of the order 2 kilofarad with low voltage limits and high power density. So capacitor is a device that stores electrical energy in the form of electrode potential. So capacitor is an electronic device which is capable of storing electrical energy in the form of electrode potential. Supercapacitors are having a high capacitance. It is of the order 2 kilofarad. And especially when we discuss about the recharge time of supercapacitors, it is extremely low. It is of the order 1 to 10 seconds. At the same time, if we discuss about the lifetime of the supercapacitors which are used in vehicles, it is high, that is of the order 10 to 15 years. So supercapacitors are having very long life, that is 10 to 15 years. Let us discuss about the description of a supercapacitor. So in general, a supercapacitor consists of a collector, separator and an electrolyte. It is the collector, containing cationic chamber and anionic chamber. It is the separator. Generally it is a porous electrode. So porous electrode will act as a separator. It consists of an electrolyte. Whenever this collector is connected to the battery, then it results in the formation of electronic double layer. So whenever a collector is connected to the battery, due to the presence of an electrolytic solution, generally electrolytic solution means it consists of positive and negative ions. So under the influence of the electric current, they migrate towards the cationic and anionic chamber, with the result at the cationic and at the anionic chambers electronic double layer will be created, and with the result it is possible to store the electrical energy in the form of electrode potential. So a super capacitor consists of a collector containing cationic and anionic chambers, separator, usually it is made up of a porous electrode, and an electrolyte. Electrolyte consists of both positive and negative ions. So due to the development of electronic double layers, it is possible to store electrical energy in the form of electrode potential. Now let me discuss about the types of supercapacitors. Coming to the types of supercapacitors, these supercapacitors are generally classified into three types. So supercapacitors can be classified into three types, namely electrostatic double layer capacitors. Second one includes pseudo capacitors, and the third one includes hybrid capacitors. Supercapacitors can be classified into three types, one being electrostatic double layer capacitors, second one is pseudo capacitors, and the third one is hybrid capacitors. So moving to electrostatic double layer capacitors, in general here the electrical energy is stored electrostatically. That means due to the creation of electronic double layer, the electric current will be stored. In general, these electrodes are made up of carbon or charcoal powder. So this is about the electronic double layer capacitors. Electronic double layer capacitors. Here the electrodes are made up of charcoal powder or carbon, and this electrolytic solution consists of both positive and negative ions, with the result at the cationic and at the anionic chambers electronic double layer will be created, and hence the electrical energy will be stored electrostatically. So moving to the pseudo capacitors, here the electrical energy is stored electrochemically. Here the electrical energy is stored electrochemically. That means through a redox reaction, here the electrical energy will be stored. So in the case of pseudo capacitors, the energy is stored electrochemically through a redox reaction. And in general, these electrodes are made up of metal oxide or conducting polymers, and especially these pseudo capacitors are having very high energy storage when compared with the electrostatic double layer capacitors. So, pseudo capacitors can store more energy when compared with electrostatic double layer capacitors. And finally, moving to the hybrid capacitors. Here, hybrid capacitors will use the principle of electrostatic double layer capacitors and also pseudo capacitors. That means in the case of hybrid capacitors, the electrodes are made up of metal oxide or metal hydroxide or conducting polymer. But remember that these electrodes are asymmetric to each other. That means at one of the electrode, electronic double layer will be created, and at the other electrode a redox reaction takes place, and hence here at one electrode the energy is stored electrostatically, and on the other electrode the energy is stored electrochemically. That means hybrid capacitor is developed by using the principles of electrostatic double layer capacitor and pseudo capacitors. Now let me discuss about the applications of capacitors. Coming to the applications of supercapacitors, supercapacitors will found immense applications in various fields, especially to store the electrical energy in the form of electrode potential. So, coming to the first application, the supercapacitors are used in consumer electronics like laptops, computers and media player. So what is the importance of pseudo capacitors? They use the principle of redox reaction and hence high energy can be stored. So coming to the important application of supercapacitors, they are used in consumer electronics, especially in laptops, computer, media player. They are also used in electric cars because the lifetime of the supercapacitors in these vehicles is high. They are also used for making cordless tools like screwdrivers. At the same time, these supercapacitors are used in RAM and SRAM in order to provide backup power. So, the backup power of the computers is mainly due to the presence of supercapacitors. At the same time, these supercapacitors can be used in different fields like military, railway, cranes, forklifts. That means for the lifting of very heavy vehicles. And it is also possible to buffer the power from or to rechargeable batteries. And one of the prompting application of the supercapacitor is these supercapacitors are used in the manufacturing of defibrillators. These defibrillators are capable of delivering 500 joules electric current in order to shock the heart to bring it to the normal rhythm. If you like the video, don't forget to like, share and subscribe. Thanks for watching. Have a nice day.